Hello and welcome to today's webcast, Conquer the Future with Streaming and Predictive Analytics. My name is Jeremy Hill and I'm your host for today's webinar. With me is Mike Schumpert, VP of Analytics and Decisions at Software AG, and Dr. Michael Zeller, CEO of Zementis. In this session, we'll be looking at the value of streaming analytics, that is the ability for organizations to respond to events in real time the moment they happen, and how predictive analytics allows organizations to take this a step further to predict that an event is likely to happen before it does, making it possible to influence the outcome. So without further ado, let me hand over to Mike Schumpert. Mike.
Thank you, Jeremy. So we'd like to organize the talk today around a few key pillars here. We're going to cover why one would even need predictive analytics. How does that differ from the other types of analytics out there? Go into just at a superficial level, kind of the fundamentals of how this works. But I think more importantly, we want to cover and make sure everybody understands how this helps, because the value one gets out of predictive analytics, is quite key, and we'll give you several examples of that. Then we'll try to kind of help you understand how to make this happen. So once we know how it works and we're excited about the value, how can we improve it? How can we make it better? And by this point, hopefully you'll be excited about where you can see it in action, and we'll follow through for some more examples. So I'd like to begin with an overview of the analytics spectrum. And the point that we want to make here is that there are many types of analytics, and they have value in their own right. They are usually trying to tackle different sets of problems, and they're answering different questions that the business has. So at the far left of the spectrum, of course, you have your descriptive analytics. Really, this is kind of your traditional business intelligence capabilities, and you're really trying to understand what happened. That's extremely important in many use cases. Even at a more granular level, you might want to get into diagnostics about exactly why something happened. So you can see that that would build upon the understanding of what happened. Then if you really want to start applying what you've learned in real time, you need streaming analytics in order to understand what is happening right now. But the next evolution that we're really going to spend our time on is understanding what will happen. And with predictive analytics, that understanding of what will happen, as we'll see, will allow you to take actions and actually change or influence the outcome of events. So let me just speak briefly, though, on the relationship between the last two types of analytics we talked about, streaming analytics and predictive analytics. These are two different techniques. They're answering different questions about what is happening and what will happen, but they're very complementary in that the predictive analytics, as we'll see, is all around building models of behavior and being able to determine what's going to happen next. But streaming analytics is very important in order to apply those models in real time so that you can respond intelligently. And a point that we'll keep coming back to, that response must be in time for there to be a chance to change the outcome. So let's look at least a high level how predictive analytics works. It doesn't matter which algorithm you're talking about, how complex it might be, all of the algorithms are based upon one simple premise. You need to understand what has happened in the past so that you can understand what will likely happen again. That is why you'll see that you need historic data for almost all of the algorithms in order to learn from the past. But once you have learned that, you can now apply those learnings to the future so that we know that when it's likely to happen again, we have a series of choices and options to change the future. But remember that all of this is dependent upon the historic data, and if you're, in your business or in your technology, you've been gathering tons of data and building a data lake of historic data. Essentially, the more data you have, the more you need predictive analytics to make sense of it, and as we will see, the sense and the outcomes, all the modeling comes from the data itself. So the more data you have, the better off you're going to be. So what do we mean by predictive analytics and algorithms? The reality is that today, predictive analytics are all around us, and we might just not recognize them for what they are. So in the entertainment field, if any of us have watched a movie, whether it be on Netflix or Amazon or various streaming services, recommendations that suggest what movies you might want to watch are really based upon a tremendous amount of history about not only what you've watched and what you've liked, but what others like you have watched and liked. It leverages all that information and is able to make a real-time recommendation of what else you might like. But even going farther back than that, credit reports and credit scores have been with us for a long time. And similarly, what we're doing there is the services, the banks, whatever, are looking at the vast historical data they have around who defaults on loans, what are the characteristics of those individuals, how does your personal behavior match the characteristics of people that have defaulted on loans. And the techniques they use are literally called a scorecard to assess your ability to pay the loan back based upon your behavior and your similarity to others that have had good credit in the past. And then more recently, whether you own one of these, whether you've seen your colleagues or your family use them, we're getting Fitbits, we're getting smartwatches, there are things all around us that are able to measure our heart. And sophisticated devices actually have algorithms built in to not only watch your immediate pulse, but look at the signature of that pulse and look for irregularities where it can even monitor it enough to the point where it could alert a doctor if a patient is in danger and needs specific monitoring for their heart irregularities. But most of us really want to know what the business value is of predictive analytics. So regardless of your industry, you will find a use for predictive analytics. We've already talked about, in the financial services world, talking about credit scores and trying to default or measure the default rate on loans. But fraud detection is a huge area for predictive analytics. You're looking for, based upon certain patterns, a prediction that it is fraud. In the retail space, you're wanting to be able to make offers at exactly the right time. Not an offer that's going to sit on the shelf, be thrown away and ignored, an offer that is pertinent and is time-sensitive based upon what the consumer is doing right then. And we'll talk about some examples around predictive maintenance, but in the manufacturing world, manufacturers have discovered that being able to do maintenance on expensive equipment at exactly the right time has tremendous cost savings. But all of these examples follow a similar vein. They're predicated on the notion that something happens, and the faster you can find out that something has happened or is about to happen, the longer it gives you to react, and the faster your response and the faster you can react, then the greater value you're going to have in your response. So if you learn about something only well after the event has happened and the opportunity for responding has closed, then you almost should not have even learned about it, other than to try to figure out how to change your processes to ensure it won't happen again. But that particular event is gone. And Forrester Research has a great term for this. Learnings of these types are perishable insights. They're insights that have value, but they have a shelf life. And if you don't learn about them early enough, they will be past their shelf life by the time you're aware of it, and therefore your response will be nil. So let's just run through a few examples of how predictive analytics can actually move us along the value chain that we looked at earlier in the analytics spectrum. In the logistics world, you've got ships trying to get from port to port, moving goods, and clearly with real-time analytics, you would be able to monitor those ships. You'd monitor the position of the berths at the port that they're heading to, etc. But with predictive analytics, you can actually take existing conditions and be able to predict the arrival time of the ship. You can look at problems that might be happening along the route and predict problems with the route and maybe suggest, therefore, that a new route needs to be taken. So you can actually, based upon these predictions, automate actions to be able to change not only the route, maybe to slow down if we know in advance that the berth is going to be occupied. When we arrive at the port, then we slow down, we save fuel, and we arrive at the berth just in time as the previous ship has left. We talked about retail earlier. Obviously, a store is trying to make maximum use out of the fact that they have a customer maybe in the presence of the store, passing by the store, passing by their new spring displays, etc. And with real-time analytics, for the first time, we really can track not just who's entering the store and who's leaving, but we can find out where they're going in the store. We can see where, which displays they're lingering in front of. And that's all great, but predictive analytics takes that to the next level to be able to say, gee, based upon the flow in the store right now and the goods that are being bought, some offers don't really need to be at 40% anymore. We're selling these latest items quite quickly. We can probably adjust that down to 30%, and still have the same amount of volume as before, but make greater profits. And likewise, I can see the flow throughout the store. I can see that even though we don't have a queue at checkout at the moment, we will have a queue at the checkout within the next 15 minutes. And so my automated action is I can proactively alert staff to come to the front of the store and man the tills and get us back on track before the problem develops. And then let's come back to that manufacturing example. So many manufacturers struggle with this issue that they have very expensive machinery that they can't afford to go down, but it's also very expensive to take that machinery out of operation and to do maintenance on it, especially if that maintenance is not yet required. So the biggest advance in this area is real-time monitoring so that you can do what is called condition-based maintenance. So I don't just change the bearings out in the generator every year. I wait until the bearings are showing signs of failure before I do that maintenance. But with predictive analytics, again, we can get even farther out in our time horizon as to being able to know only when they need to be maintained and to have enough time in advance to be able to schedule that maintenance in a cost-effective manner. So I can obviously predict a failure that's imminent, but even more useful is to be able to say, for a given part on the machinery, this is the projected remaining useful life, and I can, at my leisure, decide when to schedule service for that piece of equipment, which components to go ahead and swap out at this time while I've got the machine out of action, etc. And in the cases of imminent failures that we can predict that are going to happen in the near term, we can even automate by tying into the dispatch systems, etc., the dispatch of technicians or field personnel to change the schedule and get the equipment maintained at the appropriate time. So what does that really look like? And why does predictive analytics give us a better head start? So this is just a simple example of real data taken from a piece of equipment. It doesn't matter what the signals are, what they represent, but basically at the far right here in time, we can see that the signal started to diverge. There was definitely something different going on, and we know, in fact, that there was a failure at that time. And sometime prior to that, any human looking at this chart would have been able to make a visual identification to say, something is going wrong. Maybe I should send somebody out. And in fact, if we'd had real-time monitoring, even before there was something visual there, we could have had a threshold on one of the sensors to say that something is going wrong, we should take a look at this. However, predictive alerts really are more subtle and sophisticated than a simple threshold alert that you would get with condition monitoring. And they're looking at the correlation and the relationships between all the signals, and in fact would have been able to predict this failure much earlier in time. And as we've said before, time is money. The earlier in time that I can see the prediction, the longer I've got to react, and the more likely it is that I will be able to intervene and prevent the failure. Okay. We mentioned earlier that the data is critical. And what makes this so different than typical analytics that are, human-driven, where you've got a business analyst investigating the data and coming up with heuristics and insights, is that the data itself is what will drive the actual learning. So we're just going to use a simple example here of weather. And let's say we want to make a prediction whether or not it's going to rain. Well, we've got a few things that we can look at in our historical data here. And so the first thing we decide to look at is the day of the week. We see here that there's really an even distribution across the days of the week as to the percent of time it rained. And what we're really saying there is that there's really no relationship between the day of the week and whether it rained. If we were to make a prediction that, when it is Wednesday, it will rain, that would be a pretty bad prediction because it only rains 22% of the time. However, if we keep looking at the other data we have, we find that if there are dark clouds in the sky versus a clear sky, then there's an uneven distribution. When there were dark clouds in the sky, 77% of the time it rained. And what that tells us is that there's probably a relationship then between the clouds in the sky, whether they're dark or not, and whether it rained. And just as an example of one straightforward algorithm that's really easy to follow, you could build a simple decision tree off of this. It would go along the lines of my first branch will be whether or not there are clouds in the sky. If there aren't, I'm going to say it's not going to rain. If there are clouds, then I'm going to ask further whether they're dark or not. If they're not, I'll still say it's not going to rain, but finally, if they are dark clouds, I'm going to predict that it'll rain. Now, clearly, this is a very simple example, but it shows you the type of logic and how it is data-driven that underpins almost all algorithms that are used for predictive analytics. So, let's jump to just a brief high-level understanding of the architecture that is required to do predictive analytics. There are many modeling platforms that will do the learning and the modeling and allow you to choose different algorithms and test the algorithms for accuracy and performance, etc. Those are the likes of proprietary systems like SAS and SPSS, but also many of the open source systems like R, Python, and KNIME. And by the way, KNIME is also a partner of Software AG. Now, that's the learning and the training of the model. But then to be able to execute the model in real time, that is where we have teamed with Zementis to allow you to easily deploy the model that you trained so that you can execute it in real time. And we do that in our Apama streaming analytics technology. There's many things going on that will influence the decision. You need to be able to handle all the real-time events that are coming in. You many times need to augment that data, the event data, with information from your systems of record. So maybe what's flowing in is a sensor ID, but you need to know what machine that is coming from, how long that machine has been in service, etc. And you don't always want to go off to a database to look up that information because you need to make the prediction very fast. So some of that information will also be stored in our Terracotta in-memory data fabric. But out of that, you make a prediction, and then you can turn it into the proper actions, etc. Now, the key to success with predictive analytics is to make this whole process from training to deployment to retraining easy. And at this point, I'd like to hand it over to my colleague, Michael Zeller, to explain exactly how that works.
Thank you, Mike. Thank you. This was a great overview of what predictive analytics is and what predictive analytics can do for you. And now let's take a look at what can make predictive analytics even better. And not to give the whole story away, as you see on the slide, it is really the operational deployment, as Mike just mentioned, of those predictive models and being able to run those in real time as efficiently as possible. This is probably one of the most important strategic initiatives that you can undertake in your organization to differentiate yourself from your competitors and really create a winning strategy. But before I dive deeper into the topic, please allow me to briefly introduce Zementis as a trusted partner of Software AG here. Zementis is a software company which focuses on the operational deployment of predictive analytics, and we were named a cool vendor in data science by Gartner. Our founding vision is pretty straightforward and centers around three main topics. It's teams, models, and generating business value. The idea is that data science teams and IT can collaborate very easily and efficiently in the deployment of models, and that those predictive models then can move very rapidly from development to deployment in the IT infrastructure. And at the end of the day, that is where it generates business value. Those predictive models have to be handed over to your business, and they have to be able to make decisions and cause actions in real time, and that's where you generate maximum business value. As Mike mentioned earlier, it is really a perishable insight. Data is something that has a shelf life, and the sooner you can act on it, the higher the value will be. So it's all about the agile deployment and the operational deployment of predictive solutions that we team up with Software AG on. Now, we've looked at predictive analytics in depth here, and if you notice on the slide, it is really a path from data on the left-hand side to business value on the right-hand side, where predictive analytics is the most important gatekeeper. If you can apply data, predictive analytics on your data as effective as possible and walk the path from data to decisions and actions as fast as possible, that will generate maximum impact in your business, maximum business value. Predictive analytics is really the imperative, kind of the next step that you would go after you've done the basic business intelligence. If you applied reports and dashboards, more data and big data itself, hopefully it doesn't mean for you creating more dashboards and creating more reports. It is really getting to automated decisions and actions. And predictive analytic models are part of that path. If you automatically react, as Mike mentioned, to sensor data to predict a failure of a particular device, you can act on it. If you can predict what your customer is looking for or what the best next recommendation would be, then that drives business value. So the faster you can do that and the more predictive analytics you can apply, the more relevant your insights will be, the faster you will be able to make decisions, and the higher your advantage, your competitive advantage will be in the market, driving revenue growth, driving greater profitability on your decisions, but also lowering risk, lowering fraud potential in the process. So this is really a fundamental technology that applies across all industries. Now, today, we're facing a couple of challenges here that Software AG and Zementis together really resolve through their software stack. In the traditional development cycle for predictive analytics and data mining models, you have typically IT and data scientists work in a fairly laborious cycle on model deployment. So data scientists typically develop models in a particular tool. Let's take R, or let's take SPSS. And then at the end of the day, they actually describe the model, worst case scenario, maybe in a Word document, and say, oh, here's my requirement specification. I hand it over to IT for it to be recoded in SQL, in Java, in C++. And so this cycle takes weeks. Usually it actually takes months. And that slows down the opportunity from taking that model from the development side to operationalize it and to actually utilize it. All that time you have already discovered new insight from your data. You've built a better fraud model. You've built a better recommendation model. And your business is literally sitting there waiting for that model to be actually deployed and to be usable. And that leads to delayed insight, less accurate decisions, because you're running on a 6-month-old model, most likely. You miss opportunities and you lose value. And it really doesn't have to be that way. So these challenges, we believe, are really something of the past. It works probably, this process works probably for you if you have one simple model, or you don't need to redeploy that particular model more than once a year. But in these days where big data is driving a lot of business value, you have to be much more agile in deployment of models, deploying hundreds of models, deploying them very rapidly. Now, the solution to that is actually fairly straightforward. We know that open standards are a key for a market to evolve. Where would databases be today without SQL? Where would the internet be without HTML? Without an open standard that allows us to exchange information, we're kind of constrained. And for predictive analytics, we're in the fortunate position we have one common dominating standard and process called PMML, the Predictive Model Markup Language, that allows us to actually exchange models very effectively and very easily between different vendors, between different applications that you may be building. So you can actually use PMML as a common standard and process for all of your predictive analytic deployments. You can even hire external service providers, consulting firms to build models for you and simply tell them that they need to deliver that model to you in an open format called PMML, the standard, and you know that you can take those models and deploy them immediately. There's no custom code involved. There's no secret sauce that in a few weeks' time you won't kind of know how it actually works. It's an XML representation of your model that allows you to exchange it across the typical boundaries of your organization. And if you haven't looked at PMML, I really encourage you to take a deeper look at it. It is a very mature standard that's developed by the data mining group, and it really was meant to avoid proprietary issues and incompatibilities in the deployment of predictive models. It's an XML-based language to define those models and define everything that they need in order to be deployed and to run and to produce the right decisions for you. And it's supported by most of the leading data mining tools, and that includes really all of the commercial tools like SAS, IBM SPSS, MicroStrategy, and open source tools like R and NIME, which is one of our partners here, to really cover the whole space of predictive analytics and data mining tools that your data scientists might be using in order to build predictive models. And a little known fact is that PMML not only handles the model itself, but also the data transformations, pre and post processing, missing values, outlier treatments. These are core components of the PMML standard so that you really walk away with a business decision that is complete from data to decision, and it's all represented as part of the PMML representation of your model. The ultimate goal really for PMML as a standard is to clearly separate two tasks, model development versus model deployment. Your data scientist can focus on building the best model, and your IT department can simply take that representation in XML and deploy that model and worry about scalability, reliability, minimal latency, high throughput. Two different teams that have different concerns as part of your business strategy. But if you can separate those concerns and really have PMML as the bridge in between, it really helps streamline the overall process. And at the end of the day, it eliminates the need for you writing custom code or for proprietary model deployment solutions, which really lock you into a single path that won't give you choices down the line on a changing infrastructure. Maybe you go from a database system to a Hadoop system, different development tools. Maybe you would like to mix and match between Python and R. With PMML, all of that flexibility will be yours. Now, the previous slide was a little heavy on text, and this is really a nice overview and a graphical representation of what PMML encapsulates. It's really all of the processing from raw data on the left-hand side to the prediction on the right-hand side. And the prediction can also be a business decision, so it doesn't necessarily just have to be a score or a probability, kind of the data science speak, but it can actually be mapped into a business decision like approve, decline, fraud, alert. All of that can be encapsulated in that representation of your model. And as you see from the model signature, it would tell you very easily to identify what the model needs as input, what it returns as an output, so IT can quickly match it up with what the raw inputs have to be and what the downstream system has to expect as an output. Input validation, often you build models, but you don't think that in your operational system, sometimes, the data feed might not be perfect, and there's outliers, missing values, invalid values that will be fed to a model, and you want to make sure that the model knows how to handle those values. All of that is, an add-on benefit that's easily represented in PMML without having to custom code any of that. And that can be done across many models so that you really have a scalable process and an agile process to deploy predictive models. When I say scalable and agile, what we've done with Software AG here is to deliver solutions that really reduce time to market in a dramatic way. If you look at custom code deployments, it is not uncommon to see 6, 9, or even 12 months until a model is actually being able to be used in a production system. That's how long it takes to recode the model, to check for errors, to make sure it's actually available to roll it out. With PMML as a standard, we can accelerate the deployment timeline to days, actually minutes, if you design your process accordingly. We give it usually a few days for oversight and checks and balances across the organization, but ideally you can hit the button, out comes a PMML model, and it gets automatically deployed. So from months to days or minutes in the deployment cycle, so dramatic acceleration. What that means is also you have an enhanced accuracy of your business decisions, because now you're running on the latest and greatest model, not on a model that's 6 months older. You want to use the latest and greatest fraud detection model, not the one that was developed last year. You want to recommend to your customer, what really mimics his current profile, his current buying behavior, not the one that he had last year, because it changes over time. And this is really what gives you maximum agility and much more rapid insight for predictive analytics. Even your data science teams, data scientists are very hard to find. There's a definitive shortage in the market. So they can be much more productive, because instead of being tied up with projects to deploy predictive models, they can really focus on developing the next model. That's what they love to do. That's what they're best at. And then simply hand over PMML, the PMML representation of the model to IT to rapidly deploy the model itself. Now, if we take for granted that we can deploy faster, there's one more important part, and that's one of the key focus areas for Zementis and Software AG, which is real-time execution. Again, coming back to perishable insights. If you have data and you can deploy your model, you can act on it. But now you also need to be able to scale that action, to scale that across the organization, and to scale it with the volume of data that's coming in. Today, when you look at your organization, you may have a new big data analytics project that builds a data lake over in one part of the organization. You have the data scientists sitting in another organizational structure building predictive models on a different system. You have a CEP engine or a rules engine that makes certain business decisions, or the logic is even encapsulated in some of your business applications. And then you have your business process that's trying to float around and try to make sense out of all of that. And in order to really take advantage of predictive analytics in real time, you need to wrap this into one cohesive system, one scalable production platform that allows you to wrap streaming analytics, complex event processing, and predictive models tightly with your business process. And that is the Apama streaming analytics platform that Mike introduced earlier. It is really a very unique opportunity to wrap all of those complex processing capabilities into one cohesive stack and allow it to scale and allow it to really make decisions in real time, in milliseconds, no matter what your data volume looks like. Because today you may be experimenting with one model, tomorrow you may have hundreds of models. Today you may have a small trickle of sensor data from a few thousand sensors, but what if that scales to millions of sensors? You don't want to rewrite code for that. You can actually leverage a standards-based component system, an infrastructure stack that has done this and is doing this in really many industries in the world already. So that's what you would want to rely on, so that your business advantage and your competitive advantage really relies on the type of decisions that you make. So the models are really your intellectual property that will drive your business. the stack, the execution, and the deployment around that is what you team up with a software AG implementer. And to kind of summarize where you can execute here, maximum flexibility on the left-hand side for your data scientists, picking and choosing the data science tool of choice, the data mining tool of choice, different commercial open source tools. We see that within that realm, they can also pick different modeling techniques. Again, a very classical evolution in data science is that people used to deploy simple regression models, linear logistic regression models, but now they're moving on very, very rapidly to deploy complex models like decision trees, ensemble models like random forests, even deep neural network models, more machine learning type models. And you can only do that if you have a standardized process to move rapidly from kind of a simple representation of a model to a more complex one without the whole process breaking down in the deployment as well as in the scalability, because a more complex model needs more processing capability. So with PMML as that bridge, software AG implementers basically allow you to take those models then in PMML form and deploy them in Apama as a streaming analytics platform. You can embed them in a web method stack, but you can even run them on Hadoop in batch mode. Again, maximum flexibility for your IT department on the right-hand side to pick the right infrastructure for the model and for the particular requirements that the model has. Is it batch processing that doesn't need immediate return action, or is it something that I need to act on in milliseconds? Because if this particular part of the machine fails, it will have catastrophic, event as an outcome. And so, having the capability to pick the right platform is going to give you maximum flexibility to deploy models and to change your business models over time. So much to the theory. So how have we seen that with clients in action? Since I just spoke about machine and sensor data, the middle part is really related to the Internet of Things. IoT is probably one of the hottest topics these days that you've seen covered in virtually all magazines, technology or mainstream. And it really allows you to take sensor data, to process it, and to make intelligent decisions on that part. One of our clients here, a leading manufacturing client with worldwide presence, has really accelerated model deployment to the factory floor for predictive quality control from literally months to an afternoon. Now they can redeploy models, update models that are better in predicting quality of the parts at the end of the production line in an afternoon rather than taking usually several months to roll this out. Tremendous impact, especially if you think about a global organization with many factories worldwide, hundreds of thousands of data scientists that are developing models. Scalability was a very, very important aspect, and also the amount of data scaling to many production lines is an essential element of that deployment. In the financial industry, one of the top 10 financial institutions in the world is using the platform for fraud detection. And again, here you have a duality of fraud decisions that run in real time, where it's very, very important that you stop the transaction before it happens. So you have to be able to make a decision in milliseconds. But then also they have a parallel track for less time-sensitive decisions. The same model can go into a Hadoop cluster and run on batch mode once every day, maybe once every few hours, because there's certain decisions that are more economic to do in batch and they're not as time sensitive. Again, the same models through PMML as an open standard can go both routes. There's no manual recoding, no manual labor involved to leverage models in two different places and to be able to scale at the same time for like seasonality. Think about, in Christmas time, everybody's using their credit card much more frequently because everybody's going shopping, and of course fraud is much more prevalent. On the left-hand side, one of the leading marketing firms wanted to do more fine-grained targeting of marketing campaigns, and so they wanted to go from just a few simple models to literally hundreds of models, much more fine-grained segmentation of the customer base, and much more complex models at the same time. And the only way they could do that, they went actually from an in-house custom code to a standard-based stack. And the only way they could do that really is through leveraging PMML as a commonality here, so the data scientists could build those more complex models and then actually move them over into the execution. And again, here, real time is very important because the customer moves on very, very quickly. So if you're not able to react and make a recommendation and show the right ad in real time, the opportunity is gone. So real-time capabilities and many more complex models was one of the driving factors for them to adopt PMML as a standard in a real-time streaming analytics stack. To summarize, predictive analytics we've seen today is a key differentiator for your business. And the deployment, the operational deployment and real-time execution is how you will differentiate your organization in the market. That's what will differentiate really the leading organizations in any industry from the ones that will fall behind very rapidly. And it does not have to be complicated. I hope we were able to show to you today that predictive analytics can be as simple as develop, deploy, and run. You develop your predictive models in a flexible data mining tool environment. NIME is one of our partners here. You can go into open source like R or other tools. You can mix and match. You take those models, deploy them in a certified engine, which gives you rapid deployment through the PMML industry standard, as we've shown you through the Mantis technology. And then you're able to run those and scale them up by injecting those models into a streaming analytics platform like a Palma from Software AG. Again, these are all standardized components. There's no magic custom code here in between that will slow you down. You can focus on developing the best models, which is your ultimate business value, and you can leverage this stack and this common standards-based process to accelerate the deployment and accelerate the execution, the ultimate execution of the predictive models. And that will be key for you to succeed in a world where big data, streaming data, data volumes are growing by the day, and you should be using predictive analytics to make smarter and more intelligent decisions. And with that, I thank you for your attention, and I will turn it back to Jeremy for a few closing words. Thank you.
Thank you, Mike Zeller and Mike Shumpert, for such an informative session. And to everyone listening for your time today, we hope you enjoyed the webinar. If you'd like to find out more about the value of streaming and predictive analytics to your organization, please go to the analytics.softwareag.com link that's on the screen now. Keep an eye out on the website for our next webinar in the series on streaming and predictive analytics. We look forward to seeing you again then. Thank you.